Hey there, teachers, students. I think I owe you a little more of a demonstration regarding running a Jupyter notebook in the cloud. That's what we're up to in our sort of teacher training world. And if you're already way ahead of me, like you're a Jupyter developer and stuff, I'm going to have other material, so you might want to stick around anyway. Like, what if you're a Julia person? Well, you're supposedly using Jupyter notebooks as well. They might be rebranded in some way, but the JU in Jupyter was Julia, PY, Python, and TER, R. R, just single letter, R. Very important in data science. I think you guys know that, or maybe you're just learning that. I don't assume a lot of foreknowledge, like I'll kind of repeat myself or scroll through biographical materials to help you sort of get my time space coordinates, if you will. But anyway, back to the cloud. Let's go to Colab itself, right? So Colab, I just have to type in Colab and it fills in the rest. Research, google.com. The browser history knows probably where I want to go. And if you have a Gmail account, and you may not, so this is just FYI, if you do, then this is an option. You'll be able to use this service for free up to a point. And then, like usual, if you want to keep going with a higher level of support in terms of persistence of your work, how fast it runs, I'm not talking about people supporting you. I'm just talking about, let's see, am I doing this right? More, I'm talking about the level of service that you can expect. All right, so, oh gosh, what do I have to say GitHub, did I? No, I said recent. So under GitHub, I'm going to put the name of my repo. And you can do this too, even the same repo, because why? Actually, this isn't my repo. This is my organization, okay? Then I get to my repos, right? Next level down. So these are repos. North Pacific Yearly Meeting, Python 5, various projects, right? Things that I'm happy to share publicly. Now you can buy private repos and not share them publicly, but what I'm trying to do is I'm kind of I'm interested in this material being available to you, this teachers in the School of Tomorrow, but it's elite school we want to go to right now. And we've been talking about this particular repo now for a few videos. I get into crypto a lot more than you're used to. If you went to high school, say in the 70s, 80s, whatever, we didn't have blockchain, we didn't have encrypted web, HTTPS, TLS, SSO, whatever you call it. We didn't have those things back in the 70s and 80s, but we do now. And high school is a lot about how things work. Like, it's not that you're going to grow up to make steel, but you want to see a steel mill. You want to see a lumber mill. We show you these documentaries. It was always a privilege to get to watch a movie in school. And AV made sure you did sometimes. School was a source of that kind of stuff. So now, where do you get your videos? Wherever you're getting your best videos, that's your school, right? Don't let them tell you where you are all the time. Like, am I in school right now? No, I'm at home. Wait, couldn't I be in school at home? Couldn't I be? Ask yourself these questions. Don't let them tell you when you're in school. That's really more up to you than them. I'm in school right now. This is me in school. All right, so Quadray coordinates. This is a thing we're interested in. And what I'm going to start by doing, you see, I just pasted, or I just drilled my way down to find this in my own GitHub repo. I'm going in through Colab as a front end, looking into my 40 solutions set of repos and digging down through Elite School to this particular repo. So far, everything I've done, you could do wherever you are. Maybe you're at West Point, right? You're in your dorm and you're trying to study this stuff, right? So what we were running up against is that we couldn't install Gimpy. But you know what? I would kind of like to rerun all this and get rid of any evidence that it's ever run at all. And so factory reset runtime, that sounds kind of funny. Like what do they really mean? What's the metaphor there? What factory? What are we talking about? But I'm going to hit that and see what happens. I got nothing to lose. This is a ghost of a ghost, right? It's like these electrons are mine to play with, we could say. So scrolling up and down, is stuff going to go away? No, nothing's changed here. Runtime, run all, run before, run after, factory reset, change runtime type. So I just want everything here to go blank. Change runtime type. Gosh. See, I don't use Colab much, so I'm floundering around here as to how to go forward. But it does work. You see, if I go here and rerun this cell, we already see what it's going to do. But if I hit the arrow, it warns me. It says, hey, are you going to run this, or like, do you trust it really? And it's like, good time to pause and ask yourself. And most people, what they trust is stuff they've authored themselves. So a lot of the time when you're in Colab, you're running something you wrote. But if you're running this now, like if you're following me step by step and you're doing exactly what I'm doing, then you are running something written by a stranger, i.e. me, or someone who knows me well, whatever. It's like you're running alien code, let's put it that way. So every time I hit a run button interactively in the cloud, this is not on my local computer, I can trigger this process of installing using pip. Pip is what the Python people use to grab stuff from the cloud, like cpan for Perl. Everybody has like cargo and all this for Golang. Every language pretty much has this idea that you need more than you've got. Like there's more stuff out there, and we want to make it easy for you to grab and install more software. And so this is an important aspect of computer languages in general. You should build it in from the beginning that there's going to be such a need. Okay, and this git command, git clone, exclamation point means bypass the kernel. In other words, the runtime kernel, kernel, not, by the way, I saw Paul Romer's blog post where he's an economist. He likes Jupyter a lot because of the open source community ethic that goes with it. That is more suitable for academics, for people who are they're trained to share and be public and collaborate. When they discover our world, the open source world, it's like, yes, finally, here's people who think the way we do. Now, what I was showing in the, so I'm going to be able to add a new cell here. What I was showing in the demo earlier when I actually authored this is that even though I appear to have CD'd down into Elite School, if I do an ls, which is just list the files that are here, I haven't gone anywhere. Elite School is still under me. And even if I rerun this particular operating system command, please go down to the next level, and then I check again, I'm stuck where I'm at. And so I'm getting curious about where am I, and I'm in a place called content, and I can't really get out of there. I can't go up another level. See, here's me trying to go up a level. Let's see where I am now. I'm still there. Like I didn't get to move. I'm stuck on this floor, you could say. All right, I get an absolute path. It doesn't give me any information except content. So I'm very much in a sandbox situation. But I was able, nevertheless, to create the entire Elite School repo under me. You could say like in the basement. There's steps down and stuff can come up from it. I just can't go down there. Me being in the file tree somewhere. Always remember, you, the user, are the logged in account, are in a like a shopping mall. There's a you are here, and you're in a tree somewhere. You're a monkey in a tree when you're a user in user space, most likely. File tree. Okay, so there in my file tree is all of Elite School, including the very Jupyter notebook that we're using right now, right? Which is called what? Quadrays in Colab. So this is the actual Jupyter notebook that we are currently using, and it is enhanced over the original. Now, I changed the name, by the way. I did call it copy of, but now it's Quadrays in Collab, better name. And it's enhanced over the original, and that it has the necessary cells to get Gimpy 2 installed. And for the rest of this video, why did we need it and what are we doing? Let's just talk a little bit about Quadrays and what they are about as we close out, okay? So that was part one. You can run this in the cloud yourself. Where we are right now, what we've gotten you to, in your college dorm or your high school nerd cave or wherever you're at, you're able to get to where I'm at now, possibly. I think you can. Right? That's what this is about. So a quadray is just a vector pointing from the origin at the center of a tetrahedron, like the picture at the top, right? So I'm scrolling up to our reference tetrahedron. Now, can I make these menus go away? Collapse sections. What's that going to do to me? Just want to hide the menu collapse sections. Doesn't make the menu go away. There, that little button does. Okay, this will have to do. Oh, there's another bar I can close. There we go. So I think you can see this whole thing. So if you're similar to the idea of basis vectors in XYZ, how many basis vectors do we have in XYZ? 3. 3 positive. And then we also have secondary vectors or negative vectors. They're not considered basis vectors in their own right. They don't define any new dimensions. They're just there as helpers. But without the negative XYZ unit vectors or non-basis vectors, you wouldn't be able to get outside the first quadrant. And there are 8 quadrants, right? So you need, for addressing purposes, you have equal need for positive and negative vectors. Whereas in quadrays, we only have positive vectors. We didn't need to delve into the negatives yet, right? So we've already run all this. So I'm going to go back down to show you what I'm talking about. So the first vector, it's all positive, which means it's one of those arrows or vectors and none of the other 3. And it has a non-unit length because what we care about, even though it's a basis vector we can call it, is the edge of the tetrahedron itself, which we want to be 1. And then the volume of that tetrahedron is 1. Now you can do a Quadrays implementation without these extra features. I'm just saying it's ideally fitted to help us grasp what we do with the IVM. Bucky Fuller's word for the scaffolding that's like XYZ, except instead of dividing space into cubes, it divides space into octahedra and tetrahedra. Twice as many of the former as the latter. Octahedrons are 4 times the volume. So what we do, let's see, 14 cells hidden. Well, I want to unhide them. Okay, I guess I click there. What we do in this particular notebook, just to be clear, is that we use those 4 basis vectors in permutation to create the 12 directions to the surrounding balls in a CCP or face-centered cubic, whatever you want to call it. IVM is what we call it. And then we do a random walk within this matrix. Always starting from the origin, we create 4 like turtles. So you can see the syntax here, the Python syntax. We wander away from the origin or back towards it, whatever. We're randomly picking from 1 to 12 directions. We're picking where to go next, which sphere to hop to. And we don't stay where we are. That could be an option, but it's not included in the possibilities in this particular thing. And then when we're done with those 4 random walks to 4 ball centers somewhere in this IVM matrix, IVM, isotropic vector matrix, we take a measure of the volume at that point. But remember, relative to a unit volume of edges 1, tetrahedron of edges 1, right? So we've got a slightly different approach. Now, have I run these? Do I need to? I think I need to run these random walks and stuff. So again, I'm in the cloud. You can do this too. And if you want to add some new cells, so that would be a new random walk. Okay, here we do the random walk. Let's walk randomly. Right now we're doing it. Then import the volume taker and get all the links of this new random tetrahedron, right? It's totally irregular, has to be by laws of chance. Chances of a regular tetrahedron are very low. And chances of coplanar are very low. I've never gotten a 0 for my volume, but hey, it's always a first time. So then, create this tetrahedron object just with edge links. That's all we're passing in. And yes, order matters. It's like pick an apex, go out A, B, C from there, and then connect the base points. B to C, C to D, D back to B, D to B. Right? A is your apex, A for apex, something like that. So that's what I've done here, and now I'm going to take the volume. I have no idea what the volume's going to be. I don't know where this 1 could have come from. Oh, wait. At this point, I'm sorry. I'm doing the reference unit tetrahedron at first. I'm only computing the links based on the original basis vectors, right? Back up to the top. Original basis vectors, those are them. They're not unit length. Say you've got those, right? And now you just want to enter these links of this regular tetrahedron into our computer, into our, when I say computer, I mean volume computer, because that's what this formula, that's what this tetrahedron is set up to do, tetravolume as TV. When I bring that in as a module, it contains a tetrahedron type, right? TV.tetrahedron, TV for tetravolume. So I'm going to feed in just the reference links, which are all 1, TV1. There it is. Okay, and now we do the random walk. And there the volume is completely whole number. That's the whole point of this notebook, is that if I do a random walk, where are we doing a random walk again? Right there. If I do a random walk, so I just starting from 0, 0, 0, 0, I went 1,000 steps each time in one of the 12 directions to the corners of the cube octahedron in an IVM. I've ended up with 4 locations, and I'm now computing the 6 edge links between them. And then I'm passing those edges to my volume computer, and I'm always getting a whole number volume. And the question is, okay, here's the whole demonstration. Does this work in super high precision? And I think I must investigate that somewhere, because the whole point so far in the early part of this video was how do we do this in high precision? And so where do I get into that? Looks like I don't even use Gimpy, but I could. It's like I make that an option. Okay, so we go to a lot of work to install Gimpy 2, and then in this implementation we still haven't apparently made real work or use of Gimpy 2. So more to come. The mystery continues. Talk to you soon.